Colin, can I now ask you to open this evening's event?
Yeah, thanks, William John. Good evening, everyone. So a very warm virtual welcome to you all from the Southeast. So I hope everyone is keeping safe and well in these very strange times. And also a very warm welcome to our presenters today, Colin Doyle and William Wilson. So as John said, my name is Colin Callery. I'm chair of the Southeast Region Committee. And on behalf of the Southeast Region, I'm delighted to welcome you to today's webinar. So the future of construction product certification and innovation, a supplier's perspective. So before we kick off and I hand you over to William and Colin, just a little background on our webinar series. So the committees of the various regions and sectors had a request by the current President of Engineers Ireland, Maurice Buckley, last summer for sectoral projects in support of national recovery. So this webinar series is a collaborative effort of 7 regions and sectors in response to that call by Maurice, and it also incorporates the Southeast Region webinar series that we've been running since September. So it was christened the Sustainability Grand Tour, and we had the first event of the series last Wednesday night, which Maurice and John opened. So we had 350 attendees on the night and a superb presentation by Geary County Council and Barry Transportation on optimising sustainability by reallocation of road space. So some brilliant recent examples of enhancement of urban areas. So with details of works carried out in Dalkey, Blackrock and Dundrum. So it's stuff that's applicable to so many towns and villages in Ireland. So excellent stuff. So tonight is the second in the series. Again, an amazing response. So we had 280 people registered for tonight's event. So it's, I suppose, a sign of our lockdown times. So with regards to tonight's presentation, back in September, William Finnegan, and William is chair of the Western region, so he shared his plan for a sustainability series in response to Maurice's request. And he invited the other regions and sectors to get involved. So we as a committee of the Southeast had a chat on this, and Colin Doyle, who's on our Southeast Region Committee, he very generously offered up his services to give a talk. So Colin's background is civil and environmental, and his particular expertise in subsystems, having completed a master's in that area. So we felt that this was a great fit, and then this further evolved with Colin involving his colleague, Dr. William Wilson, who works with Roadstone in product development and commercial innovation as part of the CRH Research Lab in Bellegarde Quarry. So again, William was delighted to be involved, and William is no stranger to the Southeast, and he was recently heavily involved in the design and production of high-strength concrete mixes for the Barrow Bridge on the ARAS bypass. So that could be a talk for another night, William, so we'll have to get you back for that one. So the format of this evening is that William and Colin will present to us, which will take about 40 minutes, and then we'll have about 10 or 15 minutes questions and answers afterwards, or as long as it takes, really. So you can type in any questions you have at any stage in the Q&A box at the bottom of your screen. So without further ado, I'll hand you over to William and Colin. Thank you.
Good evening, everyone, and thank you, Colin, for the introductions. So my name is William, and I will take you through the first part of this presentation. So so just a little bit on the layout of the presentation, what we're going to talk about tonight. We'll first look at the development and certification of environmental product declarations, or EPDs. Look at the role of EPDs and certification schemes, what is the benefit of them to customers. We'll then look at the use of recycled materials in the construction industry, particularly looking at concrete and asphalt products. Then a little bit on research and innovation and how we can use research and innovation to achieve sustainable solutions, and just look at a couple of case studies on this. I'll then hand you over to my colleague Colin Doyle, who will talk a little bit about SUDs and look at some project case studies. So on sustainability, it's a global issue and it's a growing issue. Considering the last 12 months we've had, it's still there, and even more so has come to the forefront. It is showing how we need to change and strive for greatness in terms of sustainability. By 2050, it's predicted that the world's population will be almost 10 billion, and 68% of this population will live in urban areas. If we carry on with the current trends, we will need 3 planet Earths to meet our resource demands by 2050. So really, again, it does show how something needs to change. All sectors, not just ourselves in the construction sector, typically now have sustainability targets in place, whether we're looking at the likes of zero carbon or carbon neutral materials, material use and replacing materials, the energies we use, look at renewable energies and how we can change our emissions. For ourselves, being part of GCCA, which is the Global Cement and Concrete Association, which is made up of member companies of the cement and concrete companies throughout the world, they've put targets in place for their member companies to be carbon neutral by the year 2050. I just put in the link there to the GCCA website where it gives some more information on how we plan to achieve these ambitious targets. How can we actually achieve the targets? Looking at our materials and our energies. So the energies we use to produce our materials, how we can reduce their emissions, how we can look at using alternative energies and even capture their emissions. The materials we use, how we can be more efficient with them, how we can reuse them. Again, looking at this circular economy approach. And then to also achieve this, we need to monitor what our actual environmental impact is. We need to know of our products and the processes involved, what is the impact of them. For this, we can use EPDs, environmental product declarations. So what are EPDs? They're a declaration of the life cycle analysis of a product, or the resource use indicators of that product. Unlike an eco label, which really just looks at the CO2 or the waste generation, the EPD covers everything. So it's your global warming, your CO2, your ozone, and then it's pretty much everything that's involved and the outputs of that material. It's just a graph I've taken from the Construction LCA website, which shows now earlier this year to EN 15804, there's over 10,000 EPDs published. And you can see from the graph the growing interest and the growing number of EPDs that have been produced every year. This is something we've seen ourselves as a supplier, where the inquiries we get on EPDs is always increasing. So how do you actually go about developing an EPD? For the products you're looking at, you need to have 1 year's data collected. So you're looking at everything. So the materials that goes into producing that product, the raw materials, the fuels involved in the processes, your electricity, the different energies you use, the waste you generate, the water you use. And also now as well, you need to look at the life cycle in terms of the recarbonation during the life and then your wastes after life. Insignificant inputs aren't required, so the likes of where you're using reusable molds to create that product, you don't have to include them in your data. You use this data then to calculate your LCA. Again, being a member of the GCCA, we have access to their EPD tool. There's also several other third-party EPD tools that can be used. So with these tools, they're set up that you input your data, and as long as your data input is correct, it calculates your full LCA for you. You then have to engage with a third-party verifier and draft your EPD project report for the verifier. Typically then they might come back with some queries around your inputs and really ensure that your inputs are correct. Then you submit your EPD to the program operator for publication. So you're looking at your host platform. In Ireland, we have the Irish Green Building Council, the IGBC, which can act as a host platform, and there's also a European platform that can host your EPD. On the right-hand side there, I've just shown a snapshot of environmental product declaration of our thermal light block. This is an EPD we've recently finished and should be published in the coming days. Just a little bit more then on the life cycle stages required for the EPDs, what it actually is. So it's made up of 5 different stages. You've got A1 to A3, which is your product stage. So this is from a supplier's point of view, this is what we're concerned with. It's what we call the cradle to gate. So what's needed to produce that product and get it to our gate where it's ready to go to the customer. You then have the construction phase. You have the operational phase, then the C is the end of life stage, and then D, which is the loads beyond system boundaries. Up until 2019, to create your EPD, you just needed the cradle to gate, so the A1 to A3. Now you also have to include the end of life stage and the loads beyond the system boundary. Just looking at some of the key standards around creating EPDs, particularly those for cement and concrete. First of all, to create an EPD, you have to have a PCR. Your PCRs are your product category rules. And what they do is they ensure that when you're assessing or comparing two products of the same type of product from two different suppliers, that they were both assessed using the same method, that you're comparing apples to apples. And to create an EPD, you have to have these PCRs in place. Well, they're well set up for the likes of cement and concrete. For other materials, the likes of asphalt or fill, there still is working on developing these PCRs, which will allow us to better develop our EPDs for the likes of asphalt and fill and other similar materials. The key standard is EN 15804, which is your construction product PCR. You also then have 16908, which is for your cement and building lime, and 16757, which is for concrete and concrete elements. As I previously said, up in 2019, you just needed to have the product stage for EN 15804. This has now been revised. It also includes a coexistence period of 3 years, and it also considers the end of life and the beyond system boundaries in the EPD calculation. There's also some additional mandatory indicators, such as the water use, the fossil fuels and gases associated with those, and how recarbonation is used for your during your operational phase and end of life for the product. So what are the advantages of EPDs for customers or for designers or specifiers? It's how we use them in schemes, such as the HPI, the Home Performance Index here in Ireland, which is a voluntary scheme for certification. If you have HPIs, or if you have an EPD for your HPI, you can get a better score. Similarly, Levels is the European Commission, Levels was developed by the European Commission, uses real life cycle analysis to allow optimization of your building and its design, and then how it's going to perform over the life. Again, EPDs is an advantage, and also the likes of LEED and BREAM, where the scoring, the type of scoring you get will depend on the number of EPDs you have. The type of EPD you use in these schemes will influence the scoring. There's two different types mainly. You've got an industry-wide or a generic EPD. So this is where different suppliers will use the same EPD, one that has been developed for industry for that product. Then you have the product specific or type 3 EPD, which is one where when you use that product from supplier, that EPD was developed by that supplier for that product. Generally, for a type 3 EPD, gives you double the points as well as a generic EPD. A little bit more then on LEED and BREAM. Both schemes work in a similar manner. They've got different rating systems. They're used during the design, construction, operation, maintenance phases of a project, based on the energies used, the products used, and then you've also got like the likes of social aspects. For LEED, the design team collects the data and it's then assessed by the Green Building Council, the GBC. And LEED was actually the first scheme that used EPDs in their scoring system. For BREEAM, it's slightly more scientific, based around how it scores and how the project is assessed, and licensed assessors look at the evidence to give that scoring. At the minute, for both these schemes, from a supplier's point of view, our influence is quite small for what we can do for these schemes. Generally, when we do get inquiries, it's just really looking for the upstream transport distances or the amount of recycled material that is used. To get the full advantage of these schemes and to really show you the sustainability impact, you need to be looking at the use of EPDs. And again, for both these schemes, they're measurement tools. Typically, they don't come into play until during the construction phase or after a project is finished. So you're using it to score your sustainability then, whereas they don't actually influence the scoring. So you need to look at, again, how we can use the likes of EPDs in conjunction with BIM to look at your life cycle analysis as you actually design the project. Just move on now, I'll talk a little bit about recycled materials in the construction industry, mainly for asphalt and concrete products. It's not disputed the fact that there is a global reduction in aggregate resources, and from the figures I showed earlier on in the presentation, this is only going to increase. So we need to look at how we can improve the environmental impact of new construction products, while at the same time deal with the environmental costs and environmental impact associated with waste products. So we need to look at how we can recycle these materials. Recycled aggregates are reproduced from these waste in terms of if they're byproducts or coming from waste sources. And there is an opportunity to increase to increase the use of recycled aggregates, and they are a viable construction material. Of course, there are challenges associated with this. One of the key ones is acceptance of use by designers and suppliers. This was at the minute, there still is this bit of an enigma around the use of recycled materials, and that if you see the word or hear the word recycled, it's having the trust that is going to have the same performance of the virgin material. They are designed to have the same performance. Some characteristics may be slightly different, but they still do be designed to get that performance of their virgin materials. And it's just coming over, in a sense, gaining the trust in the use of these recycled materials. And also the standards that we currently use are limiting the use of recycled materials. And I'll look at a bit more of that in the upcoming slides. So firstly, I want to look at the use of recycled materials in concrete, or recycled concrete aggregate, RCA. For using RCA, it's knowing the difference between construction and demolition waste, or C&D, and the RCA. C&D is all your waste. It's looking at your concrete, your asphalt, masonry, tiles, steel. It's all that's coming off a site. Whereas recycled concrete aggregate is made up of only the concrete aspect of that waste. So to ensure that you are using recycled concrete aggregate, you need to have a correct and well-maintained feedstock management to ensure you correctly and efficiently use that material. Our colleagues in CRH in Europe are doing a lot of work in this area at the minute around C&D waste and how you can actually divide out the different wastes to reuse them. And even for the likes of recycled concrete aggregate, dividing up the materials that come from different strengths, so that you can divide out into your low strength, medium strength, high strength recycled materials, so then that you can reuse them more efficiently. Also, there's work being done on looking at the likes of material passports at the minute, which will be very beneficial for schemes such as this, because then you're going to know exactly where your products come from, what's in your product, and how it can be efficiently reused. We have quite a large concrete research and development facility in Roadstone, and it's an area we've done a lot of work on in recent years, is looking at recycled aggregates. Just some of the findings we've had, we can manufacture both coarse and fine RCA to comply with the standards. The RCA material strengths are suitable for use in concrete strength classes of higher than C30-37. At the minute, we're limited to C37 or lower. And in higher strength classes, we can actually achieve coarse aggregate replacements of up to 40%. And also fine RCA or fine aggregate can be used up to 10%. At the minute, the standard doesn't allow for any sort of fine aggregate to be replaced by recycled material. 10% does seem like quite a small figure, but when you consider for a typical cubic meter of concrete, there probably is 800 to 1,000 kilograms of fine aggregate in it, depending on the actual mix. When you consider the amount of cubic meters per concrete that's produced each year, it is a figure that does add up. As I said, some of the limitations around the use of recycled materials, especially in concrete, is the standards. So EN 206 is a specification for ready mix concrete here in Ireland, and table E.2 in that standard gives maximum percentage replacement levels of coarse aggregate and RCA. Said at the minute, it's only the coarse aggregate portion that can be replaced with recycled material. So the amount of recycled material you can use depends on the exposure classes. So for XO concretes, which we typically call our lean mixes, up to a strength class of C20-25, you can have a maximum replacement level of 50%. For C25-30 up to C30-37, the maximum replacement level is 30%. And then for C32-40 or higher, you're not allowed to use RCA. At the minute, we consider our major cities and the type of structures that are currently being used and designed. High strength concrete of C32-40 or higher is becoming quite the norm. So by being limited to a C3037 or lower, and the values that are on that, we are quite limited with how much recycled material we can use. The use of RCA should be in agreement by all parties involved in a project, and alternative to this, they're limited to 5% RCA combined of all aggregates. Next, we have the asphalt and how we can use recycled materials, or as known, recycled asphalt pavement or RAP. Asphalt pavement is 100% recyclable, and it is actually one of the most recycled materials in the world. Just give a link there to the European Asphalt Pavement Association. It's got some very interesting figures on the use of asphalt and the recycled materials. Because it's 100% recyclable, you can have savings on the natural material use, the binder and the fuel. So unlike concrete as an example, where it can be reused as an aggregate, in asphalt you can actually also reuse it as the binder. Because of this, we can actually recover 40% or higher the environmental impact of the virgin mix. It does give equivalent performance to virgin mixes, and it can be batched using two different systems, a hot or cold batching system. Typically for larger plants, you're going to be looking at a hot batching system. And Roadstone have got RAP capabilities in 5 of our asphalt plants. On the right hand side there, I've just give a picture of our Bellegarde asphalt plant. RAP is available in it using a hot batching system, and it is capable of batching up to 400 tonne of asphalt per hour. Like concrete, the use of RAP in asphalt is limited by the standards. So for the TAI specification for base and binder courses, up to 2015, you could use a maximum of 50% of RAP. And since then, we've went backwards. We're now with 30% RAP replacement as the maximum. And surface courses don't allow RAP to be used. Currently in Europe, the normal is to use 50% RAP, and new plants are actually been designed to achieve up to 90% RAP, so we're replacing 90% of the virgin mix. Like our concrete, we've got a large asphalt research and development facility located in Bellegarde, and there's a lot of work, extensive work has been done there in the last couple of years, looking at RAP and how we can increase the RAP dosage in our mixes. We're now doing trials in conjunction with the TAI to look to increase this maximum RAP percentage. We've also done production trials ourselves in one of our locations, where we've used 70% RAP in our base and binder courses and 20% RAP in our surface courses for haul roads. Again, just showing that it is possible, and I suppose how the standards are holding back. And it's something that goes not just for the likes of recycled materials and concrete or asphalt. A lot of the standards now, I suppose, are getting a little bit outdated in terms of the research that has went on in the last 10 or 15 years in producing these low CO2, low environmental impact products. It's extensive, the research, and it's quite fascinating, some of the work that is going on. So it's a case now of bringing the standards up to speed, so the standards stay in line with this research that's going on. And to meet both the long-term 2050 goals and even intermediate goals for the likes of 2025 or 2030, the standards will have to be adopted for this. Just in relation to recycled material use, I just want to mention Article 27 and Article 28 from the European Community's Waste Directive. It's by no means an area I'm an expert in. I just thought I would mention these to show that they are there, and I suppose how they relate to the use of recycled materials. So Article 27 looks at how a waste material can be classed as a byproduct, and Article 28 then looks at how a waste material can be considered no longer to have environmental or human health impacts and can be reused. So just a couple of things that need to be kept in mind when we are looking at the use of recycled materials. So just want to move on and look at a little bit in terms of research and innovation and how we can use this to achieve our sustainable solutions. Of course, it's an area we're currently doing a lot of work in, just like I suppose the rest of the construction industry throughout the world. We are looking at our products and the processes involved in our products and how we can reduce their environmental impact. So the likes of using recycled material and whatnot. And again, the likes of using EPDs and using LCA tools is quite beneficial here. It allows you really to pinpoint where you can change to increase your sustainability. It's not just from a supplier's perspective. We need to be looking at research and innovation. From a designer, specifiers, and a contractor's point of view, it also needs to be considered. For designers and specifiers, looking at what to specify, understanding what the materials LCA actually means and what its advantages are. For this, I'm just going to put out a quote here. If you're someone that has heard me talk before, it's probably a quote you're getting sick of seeing. It's one I read very early on in my PhD. It's a quote. It stood out to me, and it's something that I do think of from time to time. And for what we're moving into, it's very relevant. The paper is cements of yesterday and today, concrete of tomorrow. The quote is, contractors and owners have to realize that what is important is not the cost of 1 cubic meter of concrete, but rather the cost of 1 megapascal or 1 year of life cycle of a structure. So it's getting away from this, the negatives of the cost of using the material and looking at what's the long-term advantages. For the likes of higher strength concretes, as an example, a higher strength concrete typically will have a higher strength, and even per cubic meter might have a higher environmental impact compared to other lower strength concretes. But by using that, you can achieve a higher load bearing capacity that allows you to create thinner elements. It reduces the volume, which in turn then will reduce the volume and loads that are on different parts of the structure. Example of this I'm given is on the right hand side is of a UHP FRC bridge, an ultra high performance bridge, compared to that of a conventional concrete bridge. For this, the upfront material costs are higher and the environmental impact is higher, but over the lifetime of that structure, you get your payback. You can get less maintenance, a longer life. So it is looking at this whole life cycle, and again, looking at how we can use the likes of EPDs with software such as BREEAM to look at the LCA when we're designing these projects. And again, for the designers and specifiers, it's talking to ourselves during the construction or during the design phase, or engaging with your suppliers, finding out this is the sort of design. Is this something that's achievable? What can you offer us? Just so that everyone's reading off the one page, and you can get a better finished product from that. Just in terms of the research and innovation, just want to mention a couple of case studies of, I suppose, some projects that we've had recently. The first one is, as Colin mentioned earlier on, the Rose Fitzgerald Kennedy Bridge outside of New Ross on the Barrow River, the N25 bypass. So it's recently opened last year. So it's an 8-pier, 3-tower extratus bridge, just under 900 meters in length. Because of the low tower height associated with extratus bridges, it's got very high stress on the concrete. So you need to have a high strength concrete. And also those long pumping distances with this, both horizontally and vertically. So again, you need to have a concrete, not just achieve the strength, but also give you this workability performance. The high strength concrete using this was a C1895, and we actually produced over 4,000 cubic meters of this concrete. It's the strength of concrete. It's not something that's normal in Ireland, and definitely not in the volumes we supplied. And you think of a concrete of this strength, you're generally looking at importing or transporting aggregates long distances and using other special additions in your mix. And with engaging with designers early on and with the contractor and doing a lot of research work on this, we were actually able to produce this high strength concrete at our plant that was local to that project, and also used aggregates that were local to the plant. It was quite an achievement and quite a sustainable solution to this high strength concrete. And again, as I said, communication is key to this. It's engaging early on both with your designers and the suppliers and contractors. It's this multidisciplinary approach that we hear a lot of now. And that is the key to the success of projects. The second one then is for an asphalt, which was at Dublin Airport Red Car Park, where the DA needed to manage the stormwater at the facility, needed to be able to both drain the water and also store the water. And there was also a very challenging project schedule for this job. For this, Roadstone came up with a solution of using DuraFlow and PermaBase. So we channel the rainwater through the porous asphalt, which is the DuraFlow, So you can see in the picture in the top right hand side of how when water is poured on that material, it drains down through it. It then goes into the granular reservoir layer, which is your perma base. From this then, it can flow to the lowest point in the system where it can be stored and also can be used as a water source if required. And we supplied over 62,000 square meters of pavement for this job. Again, it not just achieved the quality required in a challenging time frame, it also gave the required environmental performance. It was a sustainable solution to this problem. So to move on from this now, I will hand you over to my colleague Colin Doyle, who will talk you through some of our SUDs products.
Evening, everybody. So just come up. Evening, everybody. Thanks to Will there. I think one figure that jumps out from Will's presentation is the fact that 78% of people will be living in urban areas in 2050. And I think from a SUDS point of view, when we Will's touched on SUDS there with permeable asphalt a minute ago. And I think going into the future, if we're going to accommodate 68% of the population in urban areas, we'll have to allow our cities to expand in a more sustainable fashion than we have in the past. I think SUDS is, I suppose, sustainable urban drainage systems. And what I'm going to talk about here, I suppose, is permeable paving. Roadstone also have a permeable DuraFlow blacktop system, which Will outlined. And we're also working on a permeable concrete, ready-mix concrete system that we'd hope to have up and going in the coming years. The drivers for SUDS are simple. It's climate change, Water Framework Directive, drained water on first flush water from rain events tends to be polluted, and it may go straight to rivers, or it may overflow sewage plants, etc. So SUDS, another driver for SUDS is planning policy statements. So different county councils are driving SUDS in different ways, depending on what part of the country you're in. It seems to be more relevant in Dublin at the moment. So SUDS is nearly mandatory in the Dublin area. The different types of SUDS is open to interpretation, but SUDS is mandatory. And as we go down the country, it's becoming more and more relevant as we go down the country. And local authority plans as well with regard to sustainable urban drainage. Benefits of SUDS are very simple. Reduced flood risk, improved water quality, increased biodiversity, because the SUDS permeable areas such as swales, such as wetlands, etc., they intend to enhance biodiversity, increase levels of green infrastructure. It creates better places to live. It creates an idea of engagement with local communities. I suppose this is becoming a bigger issue since so many of us are working from home now. Maybe we're looking at our local areas in a different way than we were before, when we were rushing in and out of work, or rushing to Dublin, or rushing back, or rushing into Cork, etc. It's adaptation to climate change and carbon management, be it in wetland areas, etc. And we hear a lot from Borden and Mona, I suppose, recently with regard to stopping of burning fossil fuels and managing the bogland areas. I suppose the main SUDS paving components is what we look at. I mean, we're really into the engineering of SUDS rather than the biodiversity end of SUDS. So we're into engineering SUDS into the built environment. And in Roadstone, we're very strong with regard to engineering background, that anything we do has an engineering background to it. So when we offer a SUDS or a permeable pavement system, we offer the engineering backup in the background to make sure the system works properly. We just look at the main components to it. The sustainable urban drainage system on a permeable paving are really the paving blocks themselves, which are simple concrete block that allows water to ingress. And then underneath we have a number of stone materials or crushed rock materials without any fines to allow the water then to permeate down, either through an Impedex, which is a woven geotextile that promotes microbial growth and treats the water as it goes through. And you'll also see SC integrates, which allows structural reinforcement within the stone itself to offer reinforcement to the whole structure, in much the same way as steel does to reinforce concrete, to ready-mix concrete. So that's what we're looking at with regard to stone build-up. With Roadstone, we're very strong on design. We think that because we offer a product, we should have a design background, and we should offer the customer something to enable them to make the system work properly. So we have a design process in place. a properly designed SUD system or constructed SUD system will allow you to reduce the use of virgin materials, because really you'll be designing the build up to make sure you're using the least amount of virgin materials. To do this, you require site plans and AutoCAD format, including proposed levels and drainage strategy. So you may have a larger site, you may decide that you're putting HGVs on one end of the site, but there's only going to be pedestrian traffic on the other end of the site. You may want one end of the site to allow water to permeate or percolate to ground. The other end of the site might decide that we can hold the water for delayed discharge, or we may be using the water in a swale or in a biodiversity area. When you design something, a design engineer takes responsibility of the permeable paving design, and the design engineer issues a site-specific permeable paving design, including construction depths, inert levels, restraints, drainage, and any other design elements. So it's a fully designed permeable paving system, or a fully designed SUD system. The design process will provide the construction details for each permeable area, a full set of drawings, and drainage calculations then through for each permeable area, and design support and design warranty. And I think when our process is that we offer a product to the customer, and we sit behind it, and we sit behind the engineering behind it. The design process should also look at different designs for loading. So as we talked about earlier on, is it going to need HGVs? Is it going to be cars or pedestrian? What's the rainfall data in the area? Is it an area that gets high rain? Each design is a comprehensive bespoke permeable paving design. So it's bespoke to that particular site. Each site is different. We'd have generic designs within our brochures for each different area. But when we take on a design of a large development, we do a comprehensive bespoke permeable paving design. And design service and materials throughout would obviously have the Roadstone warranty, and they're covered by, and the design itself is covered by professional indemnity insurance. And if we look at just a simple, this permeable paving is it's a simple process. We look at impermeable paving as opposed to permeable paving. It's a very simple process. One allows the water through, one doesn't allow the water through. And by letting the water through a paved area, you minimize the amount of growth in that area. You minimize the hazard of trips, slips and falls. You minimize the chances that there's going to ice develop on that paved surface. We're just going to look at maybe 2 or 3 case studies with regard to permeable paving or permeable paving design. Everyone will know, I suppose, a kind of a horror story of it. Permeable paving design in a supermarket that ended up taken up 2 or 3 years later or whatever. And we would say, well, it's not down to the paving itself or the permeable paving, it's down to the way it was designed. And that's why we would always push getting a professional design done. If we look at this case, it's the car park in ARAS Kildare, or Kildare County Council in Naas. Again, it was designed, the building itself was very innovative when it was designed in 2005. It was a giant Chinese-Irish architect that won a lot of awards at the time, including the Energy Ireland Building of the Year 2006. And anyone who's been in Kildare County Council in Naas would see the building as very innovative for its time. Roadstone designed the form pave aquaflow system. So we supplied the permeable paving system for the car park, which was 21,000 square metre at the time. Premier Paving did the job at the time. It's what we call a machine lay aquaflow paving block. So you'll see it being laid there on the picture on the right. It was fully designed. So it was ML machine length paving blocks and Impedex membrane, which we talked about earlier on, which is a woven geotextile that treats the water as it goes through, in a 350 mil deep sub base, which was a specification graded stone with 30% voids. All our graded stone has to have a 30% void, and you get that even under compaction, and you get that by using a crushed stone, not using a sand product, to maximize storage, and over an SE membrane to form a tank system. So the SE membrane was at the bottom of the system. This meant that the water didn't progress to ground, and it was reused through fin drains and brought back into the building. So the use of mains water was reduced by incorporating filtered rainwater from the car park. So the Impedex filtered the water as it went down, the 2 layers of Impedex, and then the water was moved through for reuse in the building as a grey water. It was stored in overhead storage tanks for non-portable water use. 16 years on, there was actually a new car park, 5,000 square metre car park, just up at the top left-hand side of that picture. That partially drains onto the permeable paving and is accommodated by the existing drainage. Kildare County Council report there's no standing water in the car park, even after major rain events. It doesn't seem to be standing water. So the system is still working 16 years on, and there hasn't been any significant maintenance done on the product. The Aquaflow ML pavement is in good condition, visually and structurally. Today the system is fully operational and providing water to overhead storing tanks for non-portable building services use as required. Now again, the grit between the paving bricks was gone, so that will have to be relayed. So you will see slight movement as you drive over the pavement, but the pavement is a block of concrete. It's doing everything it's supposed to do, and it's still working because it was designed properly and because everyone stood by the design components of the job. So the second case study is a more modern case study, is the Mary Geary Creche there in Carrytoohil there in Cork. This is a very interesting permeable paving project because it was about 500 square meters or 51 or 2 parking spaces. For the most part, the car park was in asphalt. It was a full complementary SUDs design carried out by Roadstone design team with our colleagues in Forterra in the UK. Roof water had to be accommodated within the SUDS system. And the reason that was because the only discharge they had from the creche was the sewage. And the engineer decided later on that he wasn't going to discharge 2 acres of surface water to sewage and overpower the sewage system that was going for treatment. So he made the call early on. Ray Keane and Associates, they made the call early on that we were going to try to design the system to go straight to ground. And that was, it's a very brave thing, you know, to decide to do that early on. And we had a lot of interaction with the engineering company at the start. So roof water had to be accommodated within the SUD system, and all rainwater from the 2 acre site is treated and discharged to ground. So even though some of the area of the car park is permeable, which is the parking spots, the tarmac macadam was not permeable, the roof was not permeable, the concrete paths were not permeable, the Indian sandstone at the front was not permeable, only the car parking spaces were permeable. So they had to accommodate all the water from the site and discharge to ground. So all permeable stone and geotextiles were supplied from local Roadstone sites. We have a site in Carrytoohil, one in Classis as well in Cork. So all the stones and the plastics, and then the pavement was supplied from our local plant in Limerick. The Roadstone's technical team visited Ray Keane and Associates before the project started on a number of occasions and answered any questions they had. And our support, the design team in Forterra in the UK as well, were all available to talk to. And then we had 2 site visits from Roadstone technical team to John Curran, who was the main contractor, and John hadn't done a SUD system before. So again, we stayed in touch with John and we made sure that everyone knew what was going on because the site was tight. There was a certain schedule in the products that had to arrive on site at a certain time. So we didn't want paving sitting around getting in the way. We wanted him to have a good run at the site. So he understood that as we went on, and he did a super job. So the third job we're going to look is a job, a BREEAM job in Stepaside. Again, a fully designed system. It was not a permeable, not a system that went to ground. So this was a tank system. So instead of impedex at the bottom, there was plastic at the bottom. And then fin drains took the water away for delayed discharge. So it was 450 square meters of permeable paving driveways. Again, it was done in Aquatome and Harvest Blend. We provided a full free SUDS design by the Roadstone design team. Again, we supplied them with a form, they filled it up with all their drawings, and we submitted for design. Roof water was accommodated within the SUD system. Again, this had to be done in order to fulfill the planning obligations of BREEAM in this area in Stepaside. All rainwater from the housing scheme was treated for delayed discharge. So again, the water was, instead of all the water leaving on a first flush event on heavy rain, the water is held within the system for delayed discharge and discharge on an orderly basis so as not to add to the load or the water load of local drainage systems. Again, all permeable stone, being a company like Roadstone, we're always local, we're nearly local, we're local to everyone. So all permeable stone and geotextiles supplied from local Roadstone sites. And again, we did 2, if not a few more site visits from our technical team to BREEAM homes with the builder during construction, just to make sure that they were happy with the system and it was being built as per design and as per specified, as best as the contractor could. There's some, when it comes to SUDs, I suppose there's a lot of straight permeable pavement, but there's a lot of real interesting things going on in constructed permeable systems at the minute. There's a big push into water harvesting and even some part of a push in the UK into geothermal heat transfer system. So with regard to rainwater, we just see the drawing of rainwater harvesting. So instead of leaving your water go to ground underneath your paving or your driveway, then you could take the water and put it into your rain harvesting tank for use as a grey water within the building. Now, I suppose if you're doing a retrofit system with regard to your paving, it's not as effective as in it if it's designed into the building at the start. So we're seeing more and more of these. Of course, you'll see the little blue box within the pave system. That's our distribution tank from our roof water. Rainwater harvesting has been proved in the UK can reduce household requirements up to 50%. Stores water from roofs, surfaces, impermeable surfaces and drivers, etc., can beat the hosepipe ban, which is huge in the UK. They tend to get very, very dry summers, so there tends to be a hosepipe ban in place as it's class as subterranean water. And the tank system will hold 1 cubic meter for every 10 meters of paving with a 350 sub-base depth. So for if you have a 350, which would be a typical enough build-up of permeable stone under a permeable pavement system. You can retrofit for exterior use, for car washing or gardens, etc. But for new builds for exteriors, you can use it as a grey water for flushing toilets, central heating for washing machine, etc. And the pump chamber can be installed within the driveway itself. So again, it gets very innovative as you go through the systems themselves. Now, I suppose the last one with regard to SUDs and SUDs paving systems is the geothermal heat transfer. Again, this is somewhat in its infancy in the UK, and it's something that we're definitely looking at in this over here. It's where the actual coils themselves, the heat cooling pipes, are within the paving or within the permeable paving, and then heat is transferred back through the house in the same way as an air to water heat pump. So these are new systems in place, or new systems that are coming online to deal with SUDs and to give further benefits in the SUD system. That's basically it. I just would encourage everyone to maybe look at the Roadstone Online Learn. We have a lot of online seminars, 6, I think we're up to 7 online seminars. We have a lot of how-to videos. We have a lot of case studies in place as well for visual interaction with the products or whatever you're looking to do. That's great.